So, hello everyone. Thanks for joining me on my talk about 5 levels of automated testing. My name is Petr Heinz, and I'm the lead developer and architect of Shopsys framework. We have our booth here, so maybe we already spoke. What I want to talk about is different approaches to testing, because even when you test something correctly, it might not work. So as you can see, this lock, for example, works really well. It locks, but it's on sliding door. So so this might not be really the best use case for it. So testing. The goal of testing is to assert that some functionality, some application works as intended, but you have to really define your intentions, really define what you expect. This is very important, both for automated and for manual testing. For automated testing, you of course have to be more strict. For manual testing, you can say it has to be nice, work as expected, etc., because there is the human on the other way. Even though manual testing is important and shouldn't be neglected, I'm not going to speak really about it, so I'm going to focus on the automated tests. There are several different approaches to automated testing, and in Shopsys framework we use 5 distinct layers. First one is the unit testing. Please let me see a show of hand. How many developers are here? So almost everybody. That's cool. And how many of you have ever written a unit test? Almost everybody. That's great. A few years ago, it didn't look so well on a few conferences. So unit testing, the target here is to really test the smallest amount of code possible. So typically a method. This is quite important because of the smallest amount of code you're actually executing. The unit tests are very, very fast, usually. And they help you with a really precise localization of the problem, because you typically assert that the return value is something very specific. And if it's not, you know where the problem is, and you can fix it right in that method. But the code you are testing has to be written in a specific way. This can be seen both as an advantage, because it forces us to design our code well. But on the other hand, let me see a show of hand who ever worked with a legacy application. Right? So there are different kind of testing when it comes to not optimally designed code. Due to this, unit tests are really, really great for testing well-defined, isolated components, and you can really test your application well with unit tests. So let's pray to get demo gods. I'm gonna show you a quick live demo. I think I will not show anything new to most of you, but this is what a typical unit test looks like. It's a class that has a really short testing methods. It has some data providers, so you can really test a lot of different use cases, different types of data, and you test one method at a time. And thanks to this, I can quickly connect to my Docker container with Shopsys framework running. So I'll start up bash. I'll use think, which is an automation tool, something like make, for example. So I'll run my test suits, and you can see that even though there are more than 1,000 tests in several different packages, it was finished in like 4 seconds. So this is very nice. Second type of tests are the functional tests, and they test the interoperability of different classes. They are sometimes called also integration tests, and in them you can use the services right from your dependency injection container. So you can really test the classes which are configured just like you use them in your application, and you can test them on against some higher level assertions. They may even access some database or other storages like file system or Redis, Elasticsearch, and you can really test a larger chunk of your functionality than with unit tests. This, of course, comes with a price because they are slower than unit tests, and you have to isolate the storages, the external. Well, you have to isolate, for example, data that was saved into a database. We do this, for example, by a transaction, a database transaction, which we roll back at the end of each test. I recommend having testing data fixtures, which can give you really a quick way to start testing, because you have some basic data which will be filled into your database beforehand, and you can test a lot of use cases with a well-designed data fixture. I'll show you how such functional test may look like. So as you can see, it differs from the typical unit test because there is much more code, much more classes are used. You can see that there are different objects created, and then you assert that the input price after some kind of calculation is exactly what you would expect. And you can see that we might run some checks of Redis, clean the Redis caches, and the functional tests are slightly slower, but still pretty fast. You can still run it before each of your commit on your local machine, and you don't have to wait too long. But it's not as fast as unit tests. Half a minute, I think it's fine. So those are the functional tests. They are good because you can test more. Well, the code doesn't have to be designed so well. It doesn't have to be so testable. And you can use it for slightly less well-designed applications. So even for some real legacy applications, it might be useful to functionally test some specific parts. You can also test the persistence layer, so you can know that everything is persisted correctly, and when you load it from the database, it's still the same, still what you expect. The third layer are HTTP smoke tests, which is something we've come up during development of Shopsys framework. It's a layer that doesn't check really much, but it basically takes all the routes that are registered in the router, use some default values for parameters, and then make all the requests and test only one thing, the HTTP status code. It basically answers the question if my app is 200 OK. Sometimes the 200 OK is not the exact HTTP status code we want, because, for example, if we have in our database a product that is hidden, it shouldn't be visible. So we might then configure the route with those parameters to assert that the status code is, for example, 404, or we can assert that when you are not logged in your administration, then it's 403. And even though this kind of testing isn't really very deep, the biggest advantage is it's almost maintenance-free, because it tests all your new routes automatically. So imagine that if you add a page to your application, it already is tested, at least its HTTP status code. This is pretty important because it prevents running into internal server errors on pages that you didn't really want to change in any way. So you made some change unintentionally, broke something in all the different part of your application, and if you didn't write a test for that page yourself, smoke test got you covered. They say, hey, I thought this would be this page would be found. This page would be fine, but there is 500 internal server error. So well, go check that out. There's something broken there. Because the smoke tests really do real requests on your application, they can change some things. So you need the isolation as well. It's even more important for smoke tests because they are really making requests for the new routes you register. So if you register some route that deletes your products, well, I think you should isolate your database and make sure that it won't get deleted. We have a package which is on GitHub under MIT. It's called Shopsys HTTP smoke testing, and it's a ready-to-use package for Symfony applications. So if you're using Symfony, how many of you? Just a few hands. Cool. So you should check it out. You can register it pretty simply. I can show you the page. Here we have it's quite a small package. It has some documentation, so you can really jump right into it and start testing it. I think it'll take you only like a couple of minutes to get started. So that might be interesting. Although the smoke tests aren't really very deep testing, they have very broad range. So they're still a useful companion to other layers of testing. I wouldn't recommend running only the smoke tests. But it's fine if you have a couple of unit tests, a couple of functional tests, and the smoke testing layer. So then we have the fourth layer, which are acceptance tests. They are really great at testing end-to-end scenarios because they simulate a real browser interaction. It's like a manual tester, but who's a robot. Pretty cool. It is excellent for writing specific testing scenarios for really your business critical customer paths, like creating an order or something like that, or registration. Great to have that covered. Because they test, because they really simulate a browser interaction, it can test also errors like when some div on your page is blocking, for example, a button, and it can't be clicked by the user. Most of your tests won't cover that, but acceptance tests will. Because they are really heavy, they take a while to execute. So it might not be a good idea to have really a lot of different acceptance tests because nobody wants to wait so long. For this layer, we at Shopsys Framework use Codeception and Selenium. And I'd like to show that to you. So, let's get this here. I'll start up the tests. And now let me connect to the remote desktop of my Docker container. That should be correct. Oh, well, it isn't, of course. That's not an IP address. And you can see that there are a lot of different scenarios that are being tested. There are some error messages, but that's fine because the test is testing that you cannot go into the administration when you enter a wrong password or a wrong username. It's always a good idea not to test only the happy paths, but also the expected negative behavior, like your validation, etc. So as you can see, we can really test adding to carts. We can test the whole order process, and it's pretty useful for the really important scenarios that are important for your business. So that takes me to the fifth layer, which are performance tests. Performance tests are solving the problem that when developers develop their modifications on a really small data set, which is something that is typical, they can make a really unoptimal decisions, which behave pretty fine on their local host, but when put into production, they just broke apart and fail because it's fine when you have 50 products, but when you have 50,000 products, it might have severe performance issues. You can really check it out during code review, of course, if you have senior developers that know their stuff, but it's also fine when you have a testing layer that covers this for you. So you can run the tests before you deploy it, and you can see if you increase the performance, decrease the performance, or if you broke your application completely. And if you keep the track of changes of response times, you can see some nice trends, like how your application is behaving, if it's getting slower or faster. And that's really, really nice. Of course, you need to run it on the same server, and it shouldn't be really be doing anything else than running your performance tests, because otherwise you may get corrupt results. And it might be interesting for you to try, for example, getlink, which we use time to time for load tests, because it's also a good idea to see how your application behaves not only with a lot of data, but with a lot of users as well. So with getlink, you can test hundreds of concurrent users, doing some scenarios on your application and see how it behaves. And you don't want to run those tests on your local host, because there might be some background processes that will slow it down, and you don't want a big database running on your laptop. So, and also I've ran out of memes, so no demo for you. This is a nice summary of all the layers I've talked about. All the layers have different target group, different focus. They are testing different things, and they have a different ideal application. And you can see that the unit tests are really very fast. But as you go away from the smallest amount of code, the length of execution really increases. And you can see that the difficulty of maintenance for smoke tests is really easy. And for acceptance tests, it might be harder than for different parts of your application, because acceptance tests tend to be brittle. For example, when you design some fixed header, it might block the Selenium from clicking some buttons, and then you have to fix that. So I really don't recommend having a lot of acceptance scenarios, but you should definitely cover all your business critical scenarios. So when you've implemented all that, you can be pretty sure about the behavior of your application. You can be pretty sure that it behaves well and really as you intended. But can we do more? Can you guess? We can. How many of you have some coding standards that are checked? Not as much as I would have thought. So coding standards are a way to really standardize the way your code should look. So for example, you can finally set aside the holy war of tabs against spaces, and you can just decide to go with one of them and have a coding standard checker to tell you that your tests will fail if you use spaces. It really prevents problems from coming from problematic cooperation. It can prevent you from running into merging hell, and it will allow you to develop faster. A different idea is static analysis, and I would recommend using PHP Stan here. Because it understands the code, it understands what it does, understands the types that are used, it can prevent errors even before you run the code. So that's very nice. You should check it out. And you can do some architecture sniff, which is just a way to use coding standards to enforce some of your architectural decisions. Like, for example, we use a sniff that forbids you from directly instantiating objects that have their own factory. So you really have to use the factory, otherwise the test will fail and you cannot merge. And if you do all that, you should really, really automate it. Because you can, of course, trust your developers that they will run it before they commit it. But can you be really sure? And maybe it works only on their local host. So I really would recommend having some continuous integration server. We use Jenkins for this, and we are pretty happy. But you can use a lot of different options, like Travis, Circle CI, GitLab CI, or Jenkins X, for example. There is no silver bullet. There is no good approach to testing. There is no way you can cover all your scenarios with only one approach. So I would definitely recommend you extending your tool belt, getting to know other ways to test your code, other ways to help you develop faster and more safer applications. Thanks for hearing me out. All the slides and some additional resources could be found on shopsys.com/u/tests. For example, you can register to our workshop that will show you all this in hands-on development on Shopsys framework. And of course, we can talk at our booth, which you might already visited. So thanks.
Now is the time for questions. Yeah, okay.
Hi, thank you. Thank you for doing the presentation. I have 3 questions. Hope they will be short. You mentioned when talking about functional tests that one of the benefits is that your code shouldn't be very well structured to test. I recognize this, but does it mean does it work also the other way? So if your code very well structured, you don't really need much functional tests. You can just rely on unit tests.
Well, yeah, I get your point. But I think that you should still test the persistence. You should still test the interoperability of the classes, still test the integration. So I think that functional tests have a good place in every code base.
Yeah, thanks. And that leads me to the next question about testing persistence. If you mentioned that you are relying on transaction rollback for all your functional tests, how do you really test the persistence? Because realistically, you will have different stages that will be rely on the previous in the committed stage.
Yeah, that's true. And well, it's true. We don't really test the persistence. So, but I think that we've never run into issues with this approach. So maybe it would be cool to do some other way of testing the real persistence.
Okay, thanks. And the last question, in the functional test setup, I noticed that it was quite verbose. Do you guys suffer from the verboseness of this, trying to make it more concise, or is it working fine, good enough for you?
Well, I would say it's working good enough for us. It's true that it can be pretty verbose at times, but we are trying to get better every time we write a new test. So, yeah. Thanks.
Thanks for the talk.
Thank you.
Actually, my question is regarding the smoke test.
Yeah.
For me, I think it should be already covered in the either performance test, sorry, not performance, but the acceptance test or the functional test. I'm not sure. Do you agree with me or not? Because it's just testing the HTTP requests only, right?
Yeah.
So I believe it's already covered in the functional test, right?
It might be covered, but there might be I don't know how you implement your projects, but there might be cases when you do some when you create some page, which is really not that important. It's like I don't know, terms of use or something like that, and you don't write an exact test case to cover that. So in this case, smoke tests would get you back. Does that make sense to you?
Yeah, it makes sense. Okay.
Because for the acceptance tests, you really cover the business critical scenarios, and I wouldn't really recommend to write an acceptance test for every page you make, for every route in your application.
Thanks for the talk. The smoke test, there are always pages that require a fixture for us or something. They are not always stateless. They need a post request beforehand, things like that. How do you handle this, like customer account pages that need a login state or something like that?
Oh, there is some configuration that you can really you can parameterize the routes, parameterize the pages that are visited, or you can skip that page completely. But there is some default set of parameters. For example, for every parameter that ends with ID, try 1, because in the data fixtures there might be at least some data point which has ID 1 if you use auto increment. So using that, you can get some clever default options, and that way you can really cover most of the pages. And if it's too hard, then explicitly skip it, which is always an option.
Okay.
Okay, we still have time for a few questions for you.
Thank you for the talk.
Thanks.
One question: where do you make the cut between functional and unit tests?
Well, I would make the cut when you use some service from the DI container. I would not call that unit test. If you use a couple of different classes that should work together, I would also not call that a unit test.
Okay. And an additional question, how often do you run the test? Do you, I think you do not constantly run the acceptance tests, but are the unit tests something you run constantly, or is it only on deploying or?
Well, we do all the whole test suite except performance tests on every push. So for every commit that is pushed into the remote repository, we do it on the continuous integration server, and the smoke tests, acceptance tests, and functional tests we run on our local hosts quite often, because they are pretty quick.
What means quite often?
What means quite often? Well, every time I need to check if it works. So I wouldn't say constantly, and it depends on the kind of work you do at the moment, but several times a day, I would say.
Thanks.
And one more.
Hi.
Hi.
Thanks for the talk. I would have included the HTTP tests in sort of wider deployment validation or sort of infrastructure validation testing. Do you have any sort of comments about that?
Excuse me, could you repeat the question?
So I would normally include HTTP error code testing in deployment validation. So checking, for instance, do I have the correct databases linked so I'm not connecting to a production database in a QA environment, etc. I would check things like basic HTTP requests coming back, or would you include that in, would you include those sort of tests more in your integration testing, or would you have specific deployment validation testing as a separate automated step?
Well, an automated step of deployment validation that would kind of crawl the web looks like a good idea. So maybe that would make sense. It really depends on the project and its needs, and also on your development pipeline. So I don't think there is any one right way.
Okay, fair enough.
Okay. Thank you.
Thank you very much.